Good morning, class. We are looking at 8.8 vectors. In essence, this is part 2. Since we covered a big chunk of it, so we are going to look at the synopsis of what happened last week, and we're going to move on to the new stuff. So in this section, we cover graph of vectors, position vector, add and subtract vectors, algebraically find the scalar multiple magnitude of a vector, find a unit vector, find a vector from the direction, and model or applications if you. So reminding everyone about basic trig identities. Double angle, half angle formulas, polar coordinates. In short, we have the polar axis, which is the positive side of the x-axis for a rectangular grid, and the pole or the origin. A point has coordinates x and y, which is unique in a rectangular coordinate system, but it has infinitely many ways of representation as a polar. Or theta can be r, theta plus 2k pi, or minus r, theta plus pi plus 2k pi, which means odd multiples of pi, where k is an integer. We looked at various graphs. Theta equals alpha represents a line, r equals a represents a circle, r cosine theta represents a vertical line, r sine theta represents a horizontal line, r equals plus minus 2a cosine theta or plus minus 2a sine theta represents a circle. Complex plane, we have the x-axis representing the real axis, the y-axis representing the imaginary axis, and the concept of a plus bi, or x plus yi, that is a complex number, reminding everyone that I is square root of -1. I squared becomes -1, I cubed becomes negative I, and I to the power of 4 becomes +1. And the modulus, or the size, is the same as r, or square root of x squared plus y squared. If this represents a complex number, z bar or x minus yi represents a conjugate. And in a polar format, we use the shorthand notation z equals r cis theta. By that we mean r cosine theta plus ir sine theta, and r cis theta is the shorthand notation. When we have it in polar format, it can make it easy for the product of two numbers. You just multiply their modulus, add up their arguments. If it's a ratio, you divide their modulus and subtract their modulus. And it gives rise to De Moivre's theorem, where z to the power of n is r to the power of n cosine of n theta plus I sine of n theta. Now, vector is a quantity that has magnitude and direction. So we compared and contrast vectors with scalars, lines, and otherwise. There are properties of vectors that are similar to operations of numbers when you add them up. So for example, they are commutative and associative. Then we can graph them as long as they are in the same direction. That means they're parallel, okay? And they have the same size. They are equal, again, parallel and the same direction, because they could be parallel in opposite direction. That is the negative of a vector. Magnitude of a vector is calculated as the square root of a squared plus b squared, where a and b are components. So we represent it as ai plus bj, as you can see it from the graph as well. And when we move the vector such that the initial point is at the origin, then it's called a position vector. And unit vector refers to a vector which has a size or magnitude or modulus equal to 1. So we can find the position, vector simply by using this formula. If we are given the end points, the position vector as the coordinates x sub 2 minus x sub 1, y sub 2 minus y sub 1. So again, unit vector, vector equality when the components, corresponding components are equal, the two must be equal. We can use the following in order to find the vector and its direction. V is the product of its direction and cosine alpha I plus sine alpha j, which is the direction. To find the unit vector in the direction of a specific vector v, all you have to do, divide that vector by its size. And the result will be a vector in the same direction with the modulus or magnitude of 1. To add and subtract vector algebraically, we can just add their components. This was a very simple example that shows how to add and subtract vectors. All you have to do is just add up their components algebraically. Same thing happens here. In order to find a scalar multiple and the magnitude of a vector, we follow the same. I believe this was the last piece we covered, and now we are going to look at the model with vectors, which means, in short, if we happen to have, put this in slide mode, a couple of vectors, we can add them accordingly. The resulting vector is as such, and we are going to use this concept for the sake of using it in applications. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. And reminding everyone that any vector, including the velocity vector, is the product of its modulus of magnitude times cosine alpha I plus sine alpha j. So anytime you have an application, you have to set up the drawing as follows. So we have this grid, which really represents the north, south, west, east. So a plane is flying at a speed of 200 miles per hour, north, 55 degrees east. So this is the direction, and it may not be to scale, but that's the concept. The wind is blowing from west to east. This is the direction of the wind. So V of A, this is V of W, the wind, and here's the resultant. Okay. So this is how the plane is going. This is how the wind is blowing, and this is the result, the actual result, in a matter of comparing it to the ground. So we're going to compare it to the ground as far as the speed is concerned, as far as the true course is concerned. So let's see what we have here. This is angle theta. This angle represents the true course. We are going this way. This angle represents the true course. The ground speed is the magnitude of V, miles per hour, because both of them are miles per hour. The true course is north, east, and the angle is 90 minus theta. So when we find theta, we subtract it from 90, and that gives us the true course. So that's understanding the question. First, let's look at this one and following that formula. Velocity relative to air, the direction that the plane is trying to fly. The magnitude is 200 miles per hour. And 90 minus 55, because this was 55 degrees. Okay, this angle was 55 degrees. So what is left of 90 degrees is 35 degrees. So this angle is 35 degrees. So I want to make sure we understand what's going on here. So this was 55 degrees. Okay. What about the wind? So that's as far as this one. Okay. The wind has the speed of 35 miles per hour, and the angle that it makes is parallel to the x-axis, so it's 0. So the angle it makes is 0 degrees. So this one, the angle that it makes is 0 degrees. So let's write them in this format. Let's write both of them in this format. So V sub A is 200 times cosine of 35 degrees I plus sine of 35 degrees J. And at this point, you have to put it into a calculator to find the values for cosine of 35 as well as sine of 35, and you multiply both by 200. It results in the following: 163.83 I plus 114.72 J. We do the same thing to the wind. Now, of course, cosine of 0, this we don't need a calculator, is 1, sine is 0. So simply put 35I. And as far as the velocity is concerned, look at this, plus this gives you the red one. Just add them up component-wise. So this is V sub G. So add them up component wise. This is V sub G. It's hard to see that. And so when we add them up, we add up these two numbers, everybody, these two numbers, because they both have I components, and this one has nothing to be added to. So 35 plus 163.83, and then I gives you 198.83 I. This one doesn't change. So what is the velocity? Square root of A squared plus B squared. That means this one square it, this one square it, add them up and take a root. So A is this. Let me just. So this is your A. This is your B because it's AI plus BJ. Putting it into a calculator and working them out with a whole number when we do that is 230 miles per hour. All right, so we have 230 miles per hour. Now, to find the angle theta, to find this angle, basically we are going to divide B by A or Y by X, if you will. Tan of theta equals B over A. So you can write that if you want in this manner. So tan of theta equals B over A. And theta is the tan inverse of this value, which becomes a 29.98 using a calculator, almost 30 degrees. So if this is 30 degrees, what do we want? 90 minus that. We want 60 degrees. So we have this is this B, and we have this one, north 60 degrees east. And that's the final answer. A box that weighs 1,200 pounds is suspended by two cables as shown. Find the tension or magnitude in each cable. We're going to draw what's called a free body diagram, which looks like this. So we have these angles. This is 30 degrees, makes this one 150. This is 45 degrees, and this is going down. And so what is a free body diagram? I want to remind you of something basics in physics. Free body diagrams show two or more forces acting on an object or body. If the object is in an equilibrium state, all forces must add up to zero. So let's write each one. Let's write F1, F2, and F3. And in this format, for each one, the magnitude of those, you put them in a modulus sign, which is double line as far as the absolute value sign is concerned. And this one uses 150 degrees. This one uses 45 degrees. So magnitude of F1, cosine of 150 degrees I plus sine of 150 degrees J, and F2 is the same thing but 45 degrees with the magnitude for F sub 2. For F sub 3, we know it to be 1,200 pounds with what? The I component is 0 and the J component is negative. So negative 1,200 J. Negative 1,200 J. So you can go with 270 degrees or even negative 90 degrees. So 1200 times cosine of that plus sine of that results in negative 1200. Now there's summation of f must be 0, summation of f sub I must be 0, summation of f sub j must be 0. It means if you are at this state, sum of forces must be 0. Add them up. Now, in order to add them up, I need to know what is cosine of 150 and sine of 150. And remember, 150, if you subtracted 1 from 180, gives you 30 degrees. The reference arc is 30 degrees. In the second quadrant, cosine is negative. So minus square root of 3 over 2. But sine is positive, positive 1/2. Okay. So their sum is 0. Summation of f1 plus f2 plus f3 is 0. And this one, 45 degrees, sine and cosine are both square root of 2 over 2. So now, let's add them up. Add up these three. So for example, this one is magnitude of f1 times minus square root of 3 over 2i. This one is 1/2 magnitude of f1 j, and the rest of them continue in the same manner. So again, this 2 would be f1. Okay, we just distributed. The same thing for f2 we distributed, and the last one is the easiest one. Now, the sum must be 0, which means their components must add up to 0. So anything involving I, that means these two must add up to 0. Anything involving j, that means this one, and this one must add up to 0. And this is a system of equations that is a little bit involved to solve. I'm going to show you the solution in the next page, but let me give you the final answer on this page. So next page, we are going to show you how to solve this. This is elementary algebra. The numbers are a little bit involved, but conceptually, it's just like solving any system of equations. So from the next page, which I'm going to show you, the magnitude of f1 becomes 2400 over square root of 3 plus 1 precisely. You put it into a calculator, roughly 878.5 pounds. You look at the units. Applications, you give them back with proper units. And the magnitude of f2 is square root of 3 over 2, 2400 over square root of 3 plus 1, and you put it into a calculator, gives you 1075.9 pounds, roughly, which means these are the tensions that they can undo the 1200 in essence, and they put them in a state known as equilibrium state. So I'm going to put these two, class, I'm going to put these two in the next page and solve that system for you. Again, just to show you this, you should be able to do its elementary algebra. First of all, we don't like the fractions. Let's get rid of the fractions, multiply this one by 2, this one by 2. So when I multiply this one by 2, the denominators go away. When I multiply this one by 2, the denominators go away. This becomes minus 2400, and I move it to the right. Notice these two are identical. I mean, at this level, you can multiply this one or this one by -1, add them up, or just subtract this from this or this one from that. It doesn't. You can remember subtraction is a form of addition. But if you multiply the first one by -1, this goes away, becomes positive, and this becomes negative. And now, when we add up these two, these two cancel each other. These two add up. The way you add them up, if you want to keep it as an exact, you would write square root of 3 plus 1 times the magnitude of f1. The right side, just 2400. So if I divide by square root of 3 plus 1, and that's what I showed you in the previous page, we have the answer. And again, you put it into a calculator for a rough answer, okay? And the second one, you have to use one of the original equations. For example, if you go with the equation number 1, this one, the relationship between these two is that this is the same as this one, moving to the other side, divided by square root of 2 over 2. I hope you can make this transition. First of all, you can drop 2. In other words, you're multiplying both sides by 2. You take this to the right, and you divide it by square root of 2. So basically, this number times square root of 3 divided by square root of 2. And again, the reason I'm putting this, because I want it to be exact, and use a calculator, you end up with 1075.9 pounds. I showed you how to solve the system of equations. It's very straightforward. A piano is being pushed up a ramp. A ramp inclined at an angle of 20 degrees with a force of magnitude 300 pounds. Find its weight. Well, let's see how we tackle the problem here. So first and foremost, let's see what is given. So this is pushing with a magnitude of 300 pounds. So we are pushing it this way. That means F2, which is parallel to that, is having a magnitude of 300 pounds. Class, this is parallel to this, represents the magnitude of F2. So that is given. What else is given? Let's write all the given and discuss them. Given theta is 20 degrees, this angle and this angle are 20 degrees. The magnitude of F1 represents the weight. The magnitude of F2 is given as 300 pounds. The magnitude F3 is called a normal force. So first and foremost, what is a normal force? Reminding you again of a basic definition of a normal force. The normal force is a constant force applied by a surface on an object, or is a force acting perpendicular to a surface. So perpendicular to the surface, here's the surface, the ramp, the surface of a ramp. Perpendicular to that, you can continue if you want. That is called the normal force. That is the one that acts as the reverse force of the friction, if you will. All right, now, this is 20 degrees, and this is 20 degrees. This one, we're going to say B. AC is given as 20 degrees. This is given as 20 degrees. And then it's equal to DBE, and DBE is also 20 degrees. Also, although it shows it here, I want you to see why this is the case. This is a normal force, and it is perpendicular to the surface, so it makes this one 90 degrees. And this is 90 degrees because it's the weight, right? And this is the ground. So this is 90 degrees, this is 90 degrees. So what happens is that this angle with 20 degrees add up to 90 degrees, right? Also, this angle with this one must add up to 90 degrees because this is 90, this is 90. So this must be equal to 20 degrees. This is the proof. In fact, if you have two triangles where two sides are perpendicular to each other, the two are called similar figures. So this triangle and this triangle, okay? These two lines are perpendicular, these two lines, two sides are perpendicular, therefore the two are similar. But the proof that they are similar is actually what I just went over. In any event, in the triangle of DBE, if you look at this one, where this is a 90-degree angle, maybe I changed the color, it makes it easier to see. So this is a 90-degree angle. So this angle, the sine is the opposite over the hypotenuse. The opposite is F2, which is known to be 300 pounds. And the hypotenuse against the 90-degree angle is the weight that we are looking for. So this one, we're going to replace it with 300 pounds. And so this value becomes 300 divided by sine of 20. And using a calculator, we end up with 877 pounds. Remember, sine of 20 is definitely less than 1/2. Remember, sine of 30 is 1/2, and sine is an increasing function from 0 to 90 degrees or 0 to pi over 2. So 877 pounds. Again, I'm just giving you with the whole number. You really want to pay attention to how many decimals they ask you, and you do the rounding accordingly. You should always do the rounding accordingly. In some cases, they give you the setup, the drawing. In some cases, they don't. Then you got to be able to come up with the drawing on your own. Again, reminding you of a unit vector. A vector has a magnitude of square root of a squared plus b squared. Unit vector is the vector in the same direction with the magnitude of 1, so you divide by its size. In order to find the unit vector in the same direction, first let's find the size or the magnitude, which uses square root of a squared plus b squared, which means 4 squared plus negative 3 squared, and this is 16, this is 9, the answer is 25, and square root of that is 5. So all we have to do, divide the vector v by this number, and we write as 4 over 5 times I minus 3 over 5 times j, and this is the unit vector in the same direction as the v. What you can check is the size. A squared plus b squared must be 1. So this one squared plus this one squared. So here's checking everybody. So a squared plus b squared, a squared plus b squared. Obviously, this is 16 over 25. This becomes positive 9 over 25, which makes it 25 over 25 or 1. And of course, the square root of 1 is 1. So as long as you prove this is 1, that's pretty good enough. Pretty much good enough. Find the vector from its direction and magnitude. A ball is thrown with an initial speed of 25 miles per hour in a direction that makes an angle of 30 degrees with the positive x-axis or horizontal line. Find the components of the velocity vector, that means horizontal, and vertical, that means A and B. So we want to find those. That's the bottom line. Well, so here's how the vector is drawn as a magnitude of 25 miles per hour with the direction of 30 degrees with respect to the x-axis. So the given is the magnitude is 25 miles with alpha being 30 degrees. According to this formula, we're going to use alpha. Sometimes we use theta or others. So using this, the vector is represented as the magnitude 25 times cosine of 30i plus sine of 30j. And we know cosine of 30 degrees is square root of 3 over 2, where sine of 30 degrees is 1/2. So we can replace them. So 25 times cosine of 30, which is square root of 3 over 2i, plus sine of 30, which is 1/2 j. If we multiply, we get 25 square root of 3 over 2i, plus 25 halves j. And we were to find the components. So the components are, this is A, I, plus bj. And so A, the horizontal component is 25 square root of 3 over 2, and the vertical component is 25 over 2. So the horizontal component, 25 square root of 3 over 2, if you use a calculator, is about 21.65 miles per hour. So if it's moving 25 miles per hour in this direction, the horizontal component has this speed, and the vertical is 25 over 2 or 12.5 miles per hour. So it looks like this one now. Here's the new one. So this means if we are doing 25 miles per hour in this direction of 30 degrees, the horizontal component is 2165i, and this one is 12.5j. So those are the components, everybody, A and B. Finding actual speed and direction of an aircraft. A Boeing 737 aircraft headed due south maintains a constant speed of 500 miles per hour. The jet stream is 80 miles per hour in the northeast direction. That means the wind. So it's going this way. The wind is going this way. Express the velocity v sub a of the 737 relative to air and the velocity of v of w of the jet stream in terms of I and j. Vw of the wind, w. So we have the wind, we're going to call it w. Let's see what is given. So the aircraft is doing 500 miles per hour. That is the magnitude of its speed due south, going this way. That means this angle. That means negative 90 degrees or 270 degrees. Okay. The wind is going in this direction. Its speed is 80 miles per hour. So the magnitude is 80 miles per hour, everybody. Magnitude is 80 miles per hour. What direction? Northeast. This is north, this is east, this is right in the middle. That is 45 degrees. I want to make sure we understand. So we are saying this in this direction. This is north, this is east, this direction, this angle is half of 90, 45 degrees. So the magnitude is 80 miles per hour. The direction is northeast, and northeast means theta is 45 degrees. So let me erase. So I'm going to erase this. I want to make sure we understand why we came up with 45 degrees. That's why I write that for you. So again, so that's the direction. Okay. The way it works is very simple. So the Boeing 737 is going in this direction, due south. So that is 500 miles with theta equals minus 90 degrees. And if you put it into this formula, you don't even have to do that because it's going down minus 500 J. If it's going up north, it's positive 500 J. So going south. The wind, we have it in this direction, 45 degrees. And now we really have to add these two component wise to get the velocity with respect to the ground. Okay. So the velocity of 737 relative to the air is minus 500 J because 500 times cosine of negative 90 degrees I plus sine of negative 90 degrees J. Whether you do it this way or just recognize it's minus 500 J, I just wanted you to see both. I wanted you to see the drawing, and I also wanted you to see using the formula cosine of alpha I, sine of alpha J, and we have the theta or alpha. The theta or alpha is the same thing. And so we get minus 500 J because we know this is 0 and this is negative. Same thing with the wind. We're going to write this as 80 times cosine of 45 degrees I plus sine of 45 degrees J. And each one, cosine and sine of 45 are the same. Square root of 2 over 2. And you multiply it by 80 and you write it as such. 40 square root of 2 times I plus J, or just 40 square root of 2I plus 40 square root of 2J. Either way is fine. Okay. So first thing first, the question was express the velocity V sub A and V sub W with their components relative to it. Okay, so this one relative to air, and this one is the wind. So we represented both with their components. Part B is asking to find the velocity with respect to the G of the 737 relative to ground. That means basically add them up. We already have calculated V sub A to be minus 500 J, V sub W to be 40 square root of 2 times I plus J. So all we have to do is to add them up, component wise. Add these two. Now, this one is 4d square root of 2i, and this one is 4d square root of 2j with minus 500. So we are going to write this as 4d. Let me just, so this part is 4d square root of 2i. We're going to write this one first. Plus 4d square root of 2j. And we're going to add this 2. And to be exact, for now at least, we're going to write this as 4d square root of 2i, and we're going to write this as 4d square root of 2 minus 500 times j. This is just to be exact. Find the actual speed and direction of 737 relative to the ground. In other words, we're going to find the magnitude of this as well as the angle. So first, the magnitude is the square root of a squared plus b squared. In other words, square this number, add them up. Now, and this is the angle, which means we are going to have the following situation. If we call this alpha, we can find this angle as 90 minus alpha, because they're asking for the direction. The direction will be south. This angle, which is 90 minus alpha, going east. So south, 90 minus alpha going east. So this is the magnitude, which we are going to use this number, this formula. And the direction, first we find alpha, subtract it from 90, and it becomes 90 minus alpha. This is going south, 90 degrees minus alpha, east. So let's finish the job. First, the magnitude. You have to square this number, and then you have to square this number. I just put it into a calculator, and because the speed was given as 500 miles per hour and 80 miles per hour, so I'm going to go with a whole number, although at the very least show with 1 or 2 decimals and then make a decision. So when you do the math using a calculator, you end up with 447 miles per hour. So in reality, okay, so the speed of the plane is 500 miles per hour going south. Because of the wind, the effect is it's going in a different direction with a different speed. The speed is actually 447 in respect to the ground, okay, relative to the ground. And that's the idea. And what about this angle is b over a. This is b, this is a, everybody. So b over a equals tan of alpha, b over a. So I can write this one is b, this one is a, because we have it's easier to write it on the right, ai plus bj. So b over a. This is the precise answer. So tan of alpha, putting it into a calculator, will give you an answer. And alpha is the tan inverse of this number, which gives us negative 82.7 degrees. You put it into a calculator, negative 82.7 degrees. So we have this almost negative 82.7 degrees. And this one is 90 minus that, which is 7.3 degrees. So we have the speed of 447 miles per hour. South, 90 minus alpha. Okay, so this one we have to subtract 82.7 because we just look at the positive value, 7.3 east. And that's the final answer, everybody.